So today we shall start mathematical induction. Okay. So first let me tell you what is the principle of mathematical induction. Principle of finite mathematical induction. So whatever the statement is given, we consider that statement as S of n. So let S of n be a statement of a result for each n belongs to n if the first bit S of 1 is true, second bit S of k is true. This is principle of finite mathematical induction. But for principle of complete mathematical induction, we take the third bit also, that is, we show that S of k plus 1 is true. First we show that S of 1 is true, then we assume that S of k is true, and then we prove that S of k plus 1 is true. So in this chapter we have some useful formulae. What are the formulae? Let us make a note of it. If you have sum of n terms, like 1 plus 2 plus 3 plus so on up to n terms, then the formula is n into n plus 1 by 2. Then the second formula is, if you want to find out sum of the squares of n terms, that is 1 square plus 2 square plus 3 square plus so on up to n square, that is n into n plus 1 into 2n plus 1 by 6. Then the third bit is sum of cubes of n terms. So 1 cube plus 2 cube plus 3 cube plus so on up to n cube. That is n square into n plus 1 whole square by 4. Then we use nth term of AP. What is nth term of AP? A plus n minus 1 into D. Then what is sum to n terms of AP? Sum to n terms is Sn is equal to n by 2 into 2a plus n minus 1 into D. This is sum to n terms. Then if you want to find out nth term of GP, nth term of GP is Tn is equal to AR power n minus 1. Then what is sum of n terms of GP? It is Sn is equal to A into R power n minus 1 by R minus 1. If R is greater than 1. R is greater than 1. Now we will get started with the most important LAQs. Weightage of this chapter is 7 marks in boards. 1 LAQ you get from this chapter. So take the first question, very, very important. By using mathematical induction, show that for all n belongs to n, 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on up to n terms is equal to n into n plus 1 into n plus 2 into n plus 3 by 4. So in the process of mathematical induction, we do it in 3 steps. First step is show that S of 1 is true. Then second step is assume that S of k is true. Then third step is to show that S of k plus 1 is true. But over here, whenever you have up to n terms is given, we will find out nth term first. So first you write down to find nth term. We will put the side heading to find nth term. Now you see in each term you have three numbers, 1 into 2 into 3. In the second term you have again three numbers, 2 into 3 into 4. Then in the third term you have again three numbers. So we will take first number of each term. So like we will take 1, 2 and 3. So you can see 1, 2, 3 so on is in AP. So A is the first term. D is the common difference, that is 2 minus 1 is 1. Now what is nth term here? A plus n minus 1 into D. So that is 1 plus n minus 1 into 1. That is 1 plus n minus 1. Plus 1 minus 1 cancel, that is n. You got the nth term for the first number. Now we will take the second number in each term. What is the second number? 2, 3, 4. Like see how I have taken. I have taken 2, 3 and 4. So on is in AP. So what is the first term? First term is denoted by A, that is 2. D is common difference, 3 minus 2, that is 1. Now what is nth term? A plus n minus 1 into D. Substitute 2 plus n minus 1 into 1. That is 2 plus n minus 1. That is n plus 1. Now we are moving on to the third number of each term. What is the third number? 3, 4, 5. So 3, 4, 5, so on. It is in AP. So A is 3 here. D is 4 minus 3, that is 1. So nth term is again the same, A plus n minus 1 into D. That is 3 plus n minus 1 into 1. 3 plus n minus 1, that is n plus 2. Therefore, we got the nth term. What is the nth term we got? N into n plus 1 into n plus 2. So we got the nth term. This is the first part of the problem. Now after finding the nth term, we will move on to the statement. So first let us write the statement. Let S of n be the statement that. Now the whole statement we will write. Just look at the question. 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on up to, in the place of up to n terms, we will write the nth term, n into n plus 1 into n plus 2 is equal to n into n plus 1 into n plus 2 into n plus 3 by 4. Now after writing the statement, we will start step 1 to show that S of n is true for n is equal to 1. So we will take LHS. LHS means don't take the whole LHS. Take only the nth term. So what is the nth term? N into n plus 1 into n plus 2. Now put n is equal to 1. You will get 1 into 1 plus 1 into 1 plus 2. That is 1 into 2 into 3. That is 6. Now after finding LHS, we will find RHS. What is RHS? N into n plus 1 into n plus 2 into n plus 3 by 4. Now put n is equal to 1. 1 into 1 plus 1 into 1 plus 2 into 1 plus 3 by 4. That is 1 into 2 into 3 into 4 by 4. 4, 4 cancel. That is 6. So we got LHS is equal to RHS. Therefore, S of n is true for n is equal to 1. So we are done with first step. Now let us move on to step 2. In step 2 we write, assume that S of n is true for n is equal to k. And it is mandatory to write assume that here. Don't write show that. Okay, because we are assuming that S of n is true for n is equal to k. So what we have to do here, see here we have taken the statement no, from here to here. In the place of n we will write k here. Understood? So how do we proceed? So which implies 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on up to k into k plus 1 into k plus 2 is equal to k into k plus 1 into k plus 2 into k plus 3 by 4. Take this as equation number 1. Now after that we move on to step 3. Step 2 is very easy, just substituting n is equal to k in the statement. Now moving on to step 3. In step 3 you have to show that S of n is true for n is equal to k plus 1. So which means we have to add k plus 1th term on both sides. How to find k plus 1th term? So you have to take a rough column here. In this rough, you first write down the nth term. What is nth term? N into n plus 1 into n plus 2. Now wherever you have n, you put k plus 1. Put n is equal to k plus 1. So you will get k plus 1 into n is k plus 1 then plus 1. Then n is k plus 1 then plus 2. So k plus 1 into k plus 2 into k plus 3. Now this is the term with which we are going to add on both sides. So adding k plus 1 into k plus 2 into k plus 3 on both sides of equation number 1. So now we are adding k plus 1 into k plus 2 into k plus 3 on both sides of equation number 1. So I am erasing this rough part. Now you see how we add. So 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on up to k into k plus 1 into k plus 2 plus k plus 1 into k plus 2 into k plus 3. This is the k plus 1th term. We need to add on both sides. That is equal to k into k plus 1 into k plus 2 into k plus 3 by 4 plus k plus 1 into k plus 2 into k plus 3. Now we will take only RHS and we will start proving it. So we will take the LCM here. So LCM is k into k plus 1 into k plus 2 into k plus 3 plus how to take LCM? You cross multiply. So 4 into k plus 1 into k plus 2 into k plus 3 whole divided by 4. Now we will take k plus 1 into k plus 2 into k plus 3 common from both the terms. So k plus 1 into k plus 2 into k plus 3 if I take common, what is left over? Just look at the last step. Here k is left and here 4 is left. So we get k plus 4 by 4. Now you look at the question. RHS of the question. So RHS of the question, you look at it. In the place of n, we got k plus 1. In the place of n plus 1, we got k plus 2. In the place of n plus 2, we got k plus 3. And in the place of n plus 3, we got k plus 4. So, therefore, S of n is true for n is equal to k plus 1. Finally, we need to write the conclusion. Therefore, by the principle of mathematical induction, S of n is true for all n belongs to n. Now take the next question. By using mathematical induction, show that for all n belongs to n, 2 into 3 plus 3 into 4 plus 4 into 5 plus so on up to n terms is equal to n into n square plus 6n plus 11 by 3. So here also we proceed the same way. So first put the side heading to find nth term. So in the last problem, like in each term you had 3 numbers, but here you have only 2 numbers. So finding nth term will be more easier here. So first we take the first numbers of each term. 2, 3, 4. So write down 2, 3, 4 so on are in AP. So A is equal to 2, D is equal to 3 minus 2, that is 1. And An is, what is the nth term formula? A plus n minus 1 into D. 2 plus n minus 1 into 1. That is 2 plus n minus 1. That is n plus 1. Now we take the second numbers from each term. 3, 4, 5. So 3, 4, 5 so on are in AP. So A is equal to 3. D is equal to 4 minus 3, that is 1. So An is equal to A plus n minus 1 into D. A is 3 plus n minus 1 into 1. That is 3 plus n minus 1. That is n plus 2. So what is the nth term here? Nth term is, multiply both the nth terms, n plus 1 into n plus 2. This is the nth term we got. Now we need to write the statement. So let S of n be the statement that S of n is equal to, now write the whole question. 2 into 3 plus 3 into 4 plus 4 into 5 plus so on. In the place of up to n terms, we write the nth term which we got. So n plus 1 into n plus 2 is equal to n into n square plus 6n plus 11 by 3. Now after getting the statement, we start with the step 1. Step 1 is to show that S of n is true for n is equal to 1. Now we need to take LHS. LHS is the nth term. So n plus 1 into n plus 2. That is 1 plus 1 into 1 plus 2. That is 2 into 3. That is 6. Now we take RHS. N into n square plus 6n plus 11 by 3. Now put n is equal to 1. 1 into 1 square plus 6 into 1 plus 11 by 3. 1 plus 6 plus 11 by 3. 18 by 3, that is 6. So LHS is equal to RHS. Therefore, S of n is true for n is equal to 1. Now we'll move on to the step 2. What is step 2? Assume that S of n is true for n is equal to k. So in the statement which we have written, we put n is equal to k. So 2 into 3 plus 3 into 4 plus 4 into 5 plus so on up to k plus 1 into k plus 2 is equal to k into k square plus 6k plus 11 by 3. This is equation number 1. Now we take step 3. In step 3, we need to show that S of n is true for n is equal to k plus 1. Now we need to find out the k plus 1th term. So again we take the rough column here. What is nth term? N plus 1 into n plus 2. So in the place of n, you put k plus 1. So n is k plus 1 plus 1, then k plus 1 plus 2. So k plus 2 into k plus 3. So this is the term which we have to add on both sides. So adding k plus 2 into k plus 3 on both sides. So we get 2 into 3 plus 3 into 4 plus 4 into 5 plus so on up to k plus 1 into k plus 2 plus k plus 2 into k plus 3 is equal to k into k square plus 6k plus 11 by 3 plus k plus 2 into k plus 3. Now we need to take the LCM. LCM is 3. Now you cross multiply k into k square plus 6k plus 11 plus 3 into, let us multiply these two brackets. First I will write it as it is. In the next step I will multiply. Now we need to simplify this. So let us multiply this into this, this into this, this into this. So that will be k cube plus 6k square plus 11k plus 3 into, if I multiply these two brackets, we will get k square plus 5k plus 6 by 3. Now let us multiply this 3 inside, this into this, this into this, this into this. So k cube plus 6k square plus 11k plus 3k square plus 15k plus 18 by 3. Now we need to simplify this. K cube, there is only one term. Then 6k square plus 3k square is 9k square. Then 11k plus 15k is 26k plus 18 by 3. Now this is very difficult to express in the RHS of the question. Once you look at the question, n into n square plus 6n plus 11 by 3. So we can do it. We have to factorize it first by trial and error method, one root, and then by synthetic division you have to proceed. That will become too complex. So what I will do is, I will mark this as equation number 1. I will stop it here only. And now I will do the verification. So put the side heading verification. So how do we verify it? Now put n is equal to k plus 1 in the RHS of the question. So what is RHS of the question? RHS is n into n square plus 6n plus 11 by 3. Now over here I will put n is equal to k plus 1. So that is equal to k plus 1 into k plus 1 whole square plus 6 into k plus 1 plus 11 by 3. So that is k plus 1 into, now open the brackets, k square plus 1 plus 2k plus 6k plus 6 plus 11. Over here in the first bracket I applied a plus b whole square formula. Then here I multiplied this into this, whole divided by 3. That is k plus 1 into, now we need to simplify this, k square plus 8k plus 18 by 3. Now we need to multiply these two terms. Now we need to multiply those two brackets. So first multiply k with the second bracket, then multiply 1 with the second bracket. So that is k cube plus 8k square plus 18k plus k square plus 8k plus 18 divided by 3. So that is k cube plus 8k square plus k square is 9k square. 18k plus 8k is 26k plus 18 by 3. Take this as equation number 3. Now you can see that equation number 1 is equal to equation number 2. So you can say that therefore S of n is true for n is equal to k plus 1. Hence, by the principle of mathematical induction, S of n is true for all n belongs to n. Now take this question. By using mathematical induction, show that for all n belongs to n, 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on up to n terms is equal to n into n plus 1 whole square into n plus 2 by 12. So whenever up to n terms is given, we need to find out nth term. So first put the side heading to find nth term. So what is the nth term? You can see first term is 1 square. Second term is 1 square plus 2 square. Third term is 1 square plus 2 square plus 3 square. So what will be the nth term? Nth term is 1 square plus 2 square plus 3 square plus so on up to n square. That is sigma n square. What is the formula for sigma n square? N into n plus 1 into 2n plus 1 by 6. I gave you in the formulas. What is sum of squares of n terms? N into n plus 1 into 2n plus 1 by 6. So in one line you got the nth term here. Now we will write the statement. So let S of n be the statement that S of n is equal to 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on up to, in the place of up to n terms, I will write the nth term. N into n plus 1 into 2n plus 1 by 6 is equal to n into n plus 1 whole square into n plus 2 by 12. Now we will start with step 1. What is step 1? To show that S of n is true for n is equal to 1. So what is LHS here? LHS is the nth term. N into n plus 1 into 2n plus 1 by 6. Now put n is equal to 1. So that will be 1 into 1 plus 1 into 2 into 1 plus 1 by 6. That is 1 into 2 into 3 by 6. 2 threes are 6, 6 cancel, that is 1. Now what is RHS? RHS is n into n plus 1 whole square into n plus 2 by 12. Now put n is equal to 1. 1 into 1 plus 1 whole square into 1 plus 2 by 12. So 2 square is 4, 4 into 3 by 12. 4 threes are 12 and 12 cancel, that is 1. Now you got LHS is equal to RHS. Therefore, S of n is true for n is equal to 1. Now moving on to the step 2. What is step 2? Assume that S of n is true for n is equal to k. So in the statement, we need to replace n with k. So 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on up to k into k plus 1 into 2k plus 1 by 6 is equal to k into k plus 1 whole square into k plus 2 by 12. Next we need to take step 3 to show that S of n is true for n is equal to k plus 1. So Here we need to add k plus 1th term. So let's see how to do that. First, we take a rough column where we write nth term. Nth term is n into n plus 1 into 2n plus 1 by 6. Now here put n is equal to k plus 1. So n will become k plus 1, n plus 1 will become k plus 2. But here directly we cannot write, so we need to solve it. So 2 into, in the place of n we put k plus 1 plus 1 by 6. So that is k plus 1 into k plus 2 into 2k plus 2 into 1 is 2 and 2 plus 1 is 3. So we got 2k plus 3 by 6. So this is the term with which we need to add now. So adding, let us take the step 2 as equation number 1. So adding k plus 1 into k plus 2 into 2k plus 3 by 6 on both sides of equation number 1. So we get 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on up to k into k plus 1 into 2k plus 1 by 6 plus k plus 1 into k plus 2 into 2k plus 3 by 6 is equal to k into k plus 1 whole square into k plus 2 by 12 plus k plus 1 into k plus 2 into 2k plus 3 by 6. Now we need to simplify only the RHS. So we can take, first we take the LCM. So LCM is 12. So first term we write as it is. And second term we multiply with 2. 2 into k plus 1 into k plus 2 into 2k plus 3. Now from the numerator we can take k plus 1 into k plus 2 common. So you get k into k plus 1 is left from the first term. And from the second term we are left over with 2 into 2k plus 3 by 12. That is k plus 1 into k plus 2 into, now you multiply these two, k square plus k plus 4k plus 6 by k. Now we will further simplify. So k plus 1 into k plus 2 into k square plus 5k plus 6 by k. We need to split the middle term now in the third bracket. So k plus 1 into k plus 2 into k square plus 3k plus 2k plus 6 by 12. So that is k plus 1 into k plus 2 into, if I take k common we get k plus 3. If I take 2 common we get k plus 3 by 12. So that is k plus 1 into k plus 2 into k plus 3 into k plus 2 by 12. So that is k plus 1 into k plus 2 whole square into k plus 3 by 12. Now you can look at the question. In the RHS of the question, wherever you have n, we got k plus 1. So you just see the RHS. In the place of n, we got k plus 1. In the place of n plus 1 whole square, we got k plus 2 whole square. In the place of n plus 2, we got k plus 3. Then by 12 also we got. So finally we can conclude. Therefore, S of n is true for n is equal to k plus 1. Hence, by the principle of mathematical induction, S of n is true for all n belongs to n.